So today's video we're going to be talking about finding arc measures. So first of all, some vocabulary. A central angle is an angle whose vertex is in the center of the circle. So if I look at angle ACB, for instance, ACB is a central angle. Oops. And of course, ECA, BCF, those are other central angles. Any angle whose vertex is in the center. All right, a minor arc is an arc that is less than 180 degrees. So for instance, if I'm looking at this arc here, EA, that is a minor arc because it's not going more than halfway around the circle. So the way I write that is I write EA and then I put an arc over it. And so those are the endpoints, the E and the A. And then the arc shows you that it's an arc. So EA is a minor arc in my picture. A major arc is an arc whose measure is more than 180. So, for instance, if I look at let's see here. If I go starting at E and go all the way around until I get to D, that is a major arc. And when it's a major arc, I actually have to use 3 letters to name it. So that would be angle EAD. And again, I put an arc over it. So you have the endpoints, and then you just have one of the middle points between it. So that same arc I could call EBD if I wanted to. Or if I wanted to call it EFD, I could call it that too. Those are all the same thing, okay? And then a semicircle is an arc whose endpoints are the endpoints of a diameter. And it's exactly 180 degrees. So in my picture here, for instance, EDF is a semicircle. And again, I'm going to use 3 letters to name that one. The 2 endpoints with 1 between them.
Why do you need 3 if it's
well, I wouldn't know which side of the circle you meant. If you just said EF.
Isn't it what your E is the top of the circle? So if you said EF, it's going to be right?
It might matter which side, though, depending on the problem. So you need to use 3 letters. So, because if I just said EF, it might be EDF or it might be EAF. I won't know which half you're talking about. And it could make a difference on a problem that you're doing. Okay? So yeah, so your minor arc, you just name it with the endpoints, and then the major arcs and semicircles, you name it with the endpoints and a point on the arc between them. Okay? So you guys understand how I named them all? Okay. Basically, yeah, the points go in order as you're doing the major arcs. Okay. All right. So the measure of a minor arc actually equals the measure of its central angle. And the measure of a major arc is 360 minus the related minor arc. And by related minor arc, it has the same endpoints, basically. It's the part left over. So for instance, in my circle over here, circle C, I know the measure of AB, and so I write a small m, and then I write the AB with the arc over it. That means the measure of arc AB has to equal 50 degrees because angle ACB is 50 degrees. And then if I want to know the measure of the major arc, so that would be ADB, A through D around to B. The measure of that one is going to be 360 minus 50, or 310 degrees.
How would you find the length for AB?
You can't find the length of AB unless you have a radius or a diameter. And we will get into that later, but not yet. Okay? All right. So the arc addition postulate is just like the segment addition postulate and just like the angle addition postulate that, whoops, I did not mean to do that. Here we go. The measure of an arc formed by two adjacent arcs. So the measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. Okay, that's the long way to say it. Do you guys remember the short way I used to say it when we were talking about segment addition and angle addition? Anybody remember from last semester? Still no memory of it? The pieces add up to the whole, yeah. Which again logically makes sense. So if I take the measure of xy right here and I add the measure of yz over here, it's going to equal the measure of xyz, the whole thing. Okay? Any questions there? Okay. Okay, so we're going to use some of these properties and examples. So if I look at example 1, I want to find the measure of arc RTS. So that means I'm starting at R, I'm going through T, and around to S. So it's going to equal, it's a major arc, right? So I just take the 360 I don't know why that became a 6 instead of an S over there. 360, and I subtract the related one, which is 45 degrees. And so the measure of RTS would be 315. Suppose I wanted you guys to find the measure of TR. Why don't you guys see if you can figure that out on your own. Right, we've got a semicircle, so in that case you can take 180 and just subtract the 45. Oops, not equals, but minus. And that comes out to?
135.
Yep, 135. Okay, so any questions on that? All right. Here's another one. In this one, they gave us the diameter of each arc in circle C. They told us DF was a diameter. So for DE, they've already given me the central angle. So what's DE going to measure? Right here. DE. What do you think the arc is? Yeah, I just highlighted it accidentally. Yes, 117. All right, and then they want to know DFE. So that means I'm starting at D. I'm going through F and then to E. So it's that whole thing. How did you figure 243, Zach? Yep, 360 minus 117. We got 243. Okay, and then the last one was D, E, F. So now I'm going from D to E to F. It's a semicircle, yeah, so it's 180. Okay? Not too rough, right? No. All right, this is our lovely book again, trying to make everything real world. So you join a new bank and you divide your money several ways. They give you a circle graph, but really all we want to know is angle measures, because that's what we always do when we make circle graphs, right? Measure the angles. All right, so the measure of BD. What do you guys think? From B over to D. It's essentially what I'm going to do is I'm going to use the arc addition. This arc is 55, right? And this is 105. So you didn't quite add right. But yeah, we just do the 55 plus 105. And so that one equals 160. And then BCD is going the other side over here, B through C through D. So there's two ways you could do it. I could just take the 140 and the 60, or I could take the 360 and minus 160 that I already found, either way. So 140 plus 60, we get that that one is 200. And the two of them add up to 360, which is what we would expect. Okay? All right, congruent circles. Okay, congruent circles. Congruent circles are circles that have the same radius. Oops, didn't mean to do that. And congruent arcs have to have the same radius. And they have to have the same measure. Okay, so congruent circles have the same radius, congruent arcs have the same radius and the same measure. So if we look at figure 6, we want to know whether or not the arcs are congruent. So if I look at BC and DE, they're in the same circle, so they have the same radius, and they both have a measure of 75 degrees. So yes, those are congruent. If I look at the next one, I've got AB, which is in this inner circle, and CD, which is in the outer circle. So on this one, while they both have the same measure, they have different radii, so they are not congruent. And then if I look at the third one here, I can see that they're both right angles and they both have congruent radii. So yes, they are congruent. We have congruent radii and they're both 90 degrees. All right, and one more little question here. So in the diagram, is PQ congruent to SR? Tell me why or why not. So figure that one out for yourself. Pause the video if you have to. Okay, so yes, they would be, because angles are congruent, so that means that the arcs are congruent, and therefore, and also because the radius is the same for each of them, therefore the arcs would be congruent. And that concludes the video. Thank you.